All right, in number 59, it says a Pew poll was asked for people's opinions on whether closing local newspapers will hurt civic life. All right, 430 out of 1,001 respondents said it would hurt civic life. Okay, so A says find the proportion of respondents who said that closing local papers would hurt civic life a lot. So in our case, this is just the proportion in our sample. So this is going to be 430 divided by 1,001. So 0.4296. Okay, 0.4296. So almost 0.43. Part B says find a 95% confidence interval for the population proportion who believe closing newspapers would hurt civic life a lot. Okay, and assume the Pew random poll is simple random sample. Okay, so we are trying to make a confidence interval. We want a 95% confidence interval for the population proportion P. For the proportion in the population, that would say closing the newspapers would hurt civic life. Okay, proportion of the population that believe closing newspapers would hurt civic life. So in this case, it would be p hat plus or minus our critical value, which is 1.96 for a 95% confidence interval. It's always 1.96 for 95% confidence intervals, times our standard error. The standard error is this going to be, especially because this is an estimated standard error, this is going to be p hat times 1 minus p hat divided by n. So if p hat is 0.4296, 1 minus p hat is 0.5704. So I have the square root 0.4296 times 0.5704 divided by n, 1,001 persons. So I've got this times 0.4296 divided by 1,001, and I take the square root of that, and I get a standard error of 0.0156. And I'm going to just round off right there. So my p hat, 0.4296 plus or minus 1.96 times 0.0156. 0.0156 times 1.96, this gives me, let me just run off, 0.4296 plus or minus 0.0306. So on the low end, 0.4296 minus 0.0306, this is 0.399. And on the high end, 0.4206 plus 0.0306, 0.4512. So this is my 95% confidence interval. Okay. Part C says find an 80% confidence interval for the population proportion who believe closing newspapers would hurt civic life a lot. Okay, so I'm just going to erase some of this stuff, and I'm just going to move this up. Standard error we found to be 0.0156. That number is going to stay the same. And for 95% And let me just leave this here. So my 95% confidence interval, that ended up being 0.399 to 0.4512. An 80% confidence interval is very similar. Okay, we're going to use p hat plus or minus. The number that we use for an 80% confidence interval is 1.28 times the standard error. Okay, and that's just one of the numbers from the table. Okay, so the standard error here is still 0.0156, and my p hat is still 0.4296. So I'm going to have 0.4296 plus or minus 1.28 times the standard error, which is 0.0156. So that gives me 0.4296 plus or minus 1.28 times 0.0156 is 0.01997, so this is actually going to just end up being 0.0200, just rounds off that way. So on the low end, I'm going to have 0.4096, and on the high end, I'm going to have 0.4496. So this is my 80% confidence interval. Which interval is wider? The wider one is 95% confident interval. Okay, this one is wider. Okay, it is wider because to increase the level of confidence about whether or not we have captured the true value of p, we need to make it wider, so we can have more confidence in capturing the true value of p. Okay, so let me see if I can write. Where can I write this? Where can I write this? Okay, I'm going to just write the answer to part C up at the top. Okay, or no, part D. The 95% confidence interval is wider about capturing the population p, population parameter per p. Okay, so we want to cover more space, so we make it wider.